Hey you folks, Quill18 here, and welcome to another episode of our Unity 2D physics box stacking game. Of course, it's not quite a game yet. To be a game, while we have all the mechanics in place at this point, you need to be able to win, or at least lose, or have some sort of progression, or something like that. Now, I don't think there's going to be a real win condition in this game. I think it's going to be a stack boxes as high as you possibly can before you lose kind of thing. But so the loss condition is going to be important. Also, we haven't answered the question of where the boxes are going to come from. So let's go ahead and do that. We're actually going to start with the box spawning stuff. So I've got my box and this triangle. I'm going to go ahead and remove. I'm going to make sure to apply anything that I made to this instance to the prefab. And delete that. I'm also going to turn the triangle here into another prefab. We might use that for something, and then I'll get rid of it. And the platform is good. So what I'm going to do is I'm going to make a little device that spawns boxes. So the two ideas I had is, one, you could have boxes sort of floating from the left side of the screen, very similar to how we had our setup initially, where we had these boxes that were kinematic but not affected by gravity. But what I'm going to do right now is I'm just build like kind of a little cannon that's just off screen that throws the boxes up, and then you sort of have to catch them. The advantage of it is when it does come to the arch, the top of its arch, it's going to be going nice and slow, and it should be pretty easy to grab, so we'll see how that goes. And of course, the threat of these boxes being flung that way is they could potentially knock over your tower if you're not careful enough. So let's go ahead and make we're going to make an empty. We're going to call this a, I don't know, box launcher. And then we'll add a component to it called box launcher. So we're going to make a script. Let's go ahead and open that up and see what's involved in getting this thing to run. It's going to be pretty easy, actually. Do note that this is actually going to be our last tutorial on Unity 4.5. Unity 4.6 has come out at this point, and as soon as I wrap up this tutorial, I'm going to be updating to that, and then we're going to use the new GUI system for future things. So this game here is still going to have a very simplistic GUI, just simple text, just because we don't have the new GUI system yet. But the next time we get a tutorial going, probably we'll look into the new system. Anyway, so our box launcher will need a reference to the box that we're going to launch. In fact, one of the things we could do is, instead of just having a box prefab, like a single box prefab, what if we have an array of box prefabs, and we want to make this a public? So by making an array, what we can do is we could feed in our box launcher over here. We could give it more than one. We could have it spawn both boxes and triangles and alternate back and forth, or pick them at random. I'm going to just click on the box launcher. I'm going to lock this in, and then I'm going to grab the box, hold control, grab the triangle, and then drag it into the box prefabs over here, and that way they'll both be in the list. Kind of an interesting way of doing it. We could weight it a little bit differently. We could say something like, there's 5 things in here, and we're going to have the box, in there 4 times. And if we're picking at random, 4 out of 5 times, 80% of the time it's going to be a box, but that 20% of the time it's going to be a triangle, which honestly is going to be a lot more awkward to place. And that might add an interesting difficulty feature. What if we add another shape in here? I have another graphic kicking around from the same graphic pack, which is a circle with, some little dents and stuff just to look interesting. So what if we've got to unlock our box inspector. What if we take this circle here, we're going to call it circle. We've got box, triangle, and circle now. We're going to have to add, of course, a rigid body 2D. We'll also have to add a collider, and it's pretty obvious we're going to want a circle collider 2D. Unity by default will set the radius to be more or less correct for the circle. Looks pretty good to me. I'm going to go ahead and add a little bit of a linear drag and angular drag, just like we've added for some of our other prefabs. I'm going to go and drag the circle into the prefab array, delete this one, and on our box launcher, I'm going to replace one of these boxes, doesn't matter which one, with the circle element. So now it's going to be even more of a difficult game because we're going to have these objects that sort of like roll around and don't stand properly. So let's go ahead and see what that does. So our box launcher script right now, all we've done is added the public array so we can feed it some box prefabs. And then we're going to want some sort of timer for how frequently it shoots, some sort of cooldown timer. So let's do something like public float fire rate or fire delay, the amount of time between shots. We'll start it off at like 3 seconds or something like that. Then what we need to do is something like next fire. And we'll have it start off at something like 1 second. So when they start the game, they'll have a second, it'll shoot, and then every 3 seconds we'll get another box. And we'll see exactly how that goes. So in our update routine, we're going to want to create our boxes at that point. In fact, because we're adding something to the physics system, I feel like it might be better to put it into fixed update. We are creating a physical object. So let's go ahead and do it in the fixed update inside the physics time loop. So very simple. Next fire is going to be decreased or decremented by delta time. Again, a lot of people say when you're in fixed update, like, oh, you should use fixed time. When you're inside a fixed update, delta time is set to fixed time, so this will always work perfectly fine. And then if next fire is less than or equal to 0, then we spawn a new box. We also need to make sure to set next fire to be equal to our fire delay. There we go. In fact, I tend to like to do this as the first thing in the loop because it makes it, I don't know, super obvious about what's going on and that I haven't forgotten to reset the cooldown timer over here. So how do we spawn a box? Of course, that's a pretty common operation in Unity. We use the instantiate command. Instantiate, then we pass it a prefab. Well, we have an array of box prefabs. So we need to pass it one of these. So we could pass it the first one an array by just hitting 0. So if we want to pick one at random, we can use random.range from 0 to the length of our array. The length of the array right now will be 5. The random range here, because these are integers, will return a number from, it'll return 0, 1, 2, 3, or 4. It'll return the second number -1 as limiter, which is good because the array of our index goes from 0 to 4, despite being a length of 5, of course. It'll need a position. Well, let's instantiate it where our launcher is. So transform.position. That way, if we move our launcher around, we'll shoot it from a different spot. And then the third thing it needs is a rotation. Tell you what, let's go ahead and break this up into multiple lines over here. This third thing it will need is a rotation. So we could do a couple of things. It's common to just say something like quaternion.identity. This means basically no rotation. But what if we also set the box's initial rotation to our own rotation? So in transform.up. So what do I mean by that? If we go, so here's our box launcher. Let me go ahead and center this and then double click on it to zoom in. If we take this launcher and move it, say, just off to the side of the platform over here, and then we go into rotation mode and rotate it just a little to the left. Now, if we go back into move mode, if you are on global over here, then the green arrow will just point up. But if you go to local, the green arrow will point in the direction of your up vector. And you can see the angle that this box launcher is kind of rotated to. Well, we could use that as our sort of fire angle over here. I think that's a pretty good idea. And when we spawn a box, it'll be rotated in that direction, and it'll look a little bit better. What is it complaining about? Oh, of course, derp. Hang on, we don't want to give it the transform.up, we just want to tell it transform.rotation. We want to rotate the object we spawn based on the rotation of our box launcher. Now, instantiate will return an object for us. So we're going to do something like game object, the box geo. Oh, my spelling is off. No, it's not. Okay, good. So we're going to save the object that is instantiated here. We're going to put it into this variable temporarily so we can access it and do some things. Should be noticed is instantiate actually returns an object, not a game object. So we have to do a cast. I mean, it's spawning a game object, but by default the variable is there. So we have to explicitly let C# know that, hey, this is actually a game object. We're going to stuff it into there. Great stuff. Now we can do things to the box game object. And specifically, what we're going to do is the box game object that we spawn, which might be a box or a triangle or a circle, whatever. We'll just call it the box launcher, that's fine. It's got a rigid body 2D, and we want to give it an initial velocity. We want to give it an initial velocity because we're shooting it out of a cannon. We could also, instead of setting, we can set a velocity this way, or instead of setting a velocity, what we could do is add force. All those things are fine. I'm going to go ahead and, I don't know, we'll set the velocity just because we've been using velocity modifications all along. And then the question becomes, how strong and in what direction do we set this velocity? So let's go ahead and make a public float initial velocity and set it to something like 10. Or we could call it maybe fire velocity. I like that. The speed at which we're going to fire our object out of our little cannon. So we're going to want to set something like our velocity will be actually a vector 2, with 0 in the x and our fire velocity in the y. That would shoot it straight up. We want to rotate that based on the rotation of our object, or our box collider. We can use either the object's rotation or the box collider's rotation because they're exactly the same because of this. So then if we take our transform dot rotation multiplied by that vector, so now our velocity will be set in our current, based on our current rotation. So let's go ahead and see exactly what that might do. Drag speed is assigned but never used. Really? In our mouse manager? Oh, that's right, of course. We don't need this drag speed anymore. This is what we needed when we were setting a velocity on our drag. But since we're using a spring joint, we don't need that anymore. May as well get rid of the redundant variable. So let's hit play and see what happens. So after 1 second, this should shoot a box at random. Hey, that's working pretty good. And then after that, every 3 seconds. And then we can catch this box, put it down here, catch this box. It's actually a little hard to control with the spring. I might have to decrease the spring length or make the spring a little less just sort of springy. Depends on what kind of difficulty we want. Oh, it's definitely a little on the tricky side here. In our mouse manager, we set all of our spring here. Let's make it a much shorter and tighter string. Something like that. And we're going to increase the damping ratio and frequency. That should make it a shorter spring, but also just a tighter, less springy string. There we go. That might be good. Do we have the drag set on our box? And we do. So I mean, it's one of those things you can definitely tune forever, depending on exactly what kind of experience you might want. In fact, you might, instead of using this sort of spring mechanic, you very well may want to simply go back to a setting of velocity. Depends on the sort of experience you're going for. Oh, I can't stack. Whoa! Can't stack that. That might be a little too aggressive. If you have a longer spring, then it will be a little bit slower. And if it's not quite as stiff over here, then it will also, it'll have a bit more give when you grab things. It'll stretch a bit more. There, that might be better. So we're going to try to avoid having anything fall off, which is going to be really hard if we keep spawning these circles. There we go, another box. Drop that in there. Then we'll stack things on top of all this. Try to build a tower. The triangle's an awkward shape, but you know, we'll make do with it somehow. There's another triangle. Oh no, I've toppled over my tower. Whoa, I'm spinning things around like crazy. Triangle has its settings. We might want more linear drag or angular drag to slow that down. Right now, you know what? It's fine. So we're correctly shooting objects. Now, right now we have one box launcher. We might want one on both sides. We could have them alternate. There's a few different ways we can do that. One of the things we could just do is like tune the delays. That's not a bad idea, actually. Let's set them both to have a fire delay of 6. So we're going to have one box launcher over here. I'm going to duplicate this. Go into world coordinates. Actually, I'm just going to put a -x, so they'll be the same thing, and we'll minus the rotation. So now their rotations are exactly the same, but in opposite directions. They both have the 6-second fire delay. And what we're going to do is we're going to change our box launcher so that our next fire will actually start it as public. And by doing that, we can access it. So what we're going to do is we're going to set the box on the right to fire after 1 second and the box on the left to fire after 4 seconds. So that way they will be firing constantly at 3 seconds apart. So if we go ahead and hit play, and they'll alternate. So box number 1, box number 2, another one, a circle. Actually might go back to the velocity version for this particular box dragging game, the way I've got it. I actually think I would like to do that. So in our mouse manager, I'm going to undo some changes. Well, I'm not going to undo some changes. I'm going to add a mode. I'm going to do public bool use spring. And I'll set it to false here. So how is it going to work? We're going to grab the object here. If use spring, then we're going to create all the springs. Else, we're not going to create the spring. we're using velocity instead. If we're using velocity, I guess one of the things we're going to want to do is our grabbed object. We're going to want to turn the gravity scale off. Okay, this is when we release things. If use spring, then we're going to have to make sure to destroy the spring joint like that. Else, if we're not using the spring, we're going to have to turn the gravity scale back on. There we go. So now we can choose which way we want to do this, which is kind of great. Fixed update. I'm going to change this slightly. It's more like if grabbed object not equals null. If use spring, then we use this variant. Else, we are simply doing the thing where we go, oh, we lost our velocity thing. Float velocity ratio equals 4f. If we aren't using a spring. So I'm just going back and re-adding some things. It'll be really great to have this toggle. So here what we're doing is in our grabbed object dot velocity is going to be equal to the difference between the mouse world position 3D less our own position. That is the direction. We had that before. It's the direction times the velocity ratio is what we're setting the velocity to. And then the last thing we want to do is in our late update here, again, we're going to do if grabbed object not equals null, if use spring. This is just to make our line drawing proper. If use spring, we're going to set the positions based on that stuff. World anchor. Grab the object, transform point anchor. Yeah, okay, that's fine. So otherwise, our dragline position, since we don't really have a grab point, our dragline position 1 is simply going to be our grabbed object dot position dot x. And our position 2 is going to be where our mouse is. So we're going to need the position of the mouse. World position. World position. Okay. I realize I'm doing a lot of stuff very quickly here, not necessarily explaining, but I'm mostly putting things back. We'll see how many errors we got. Ambiguous call. Yeah, I was a little concerned about this because we're subtracting a 3D vector and a 2D vector. I could just store. This conversion here works. It'll change it from a vector 3 to a vector 2. That should work out of the box. Indeed it does. And there we go. We're back to the version where we've got the velocity. And if I go into our script and say use spring, now we should be back at the spring version. And we are. Toggle that off, hit play. We're back at the velocity version, which I think for this particular game is just making things a little bit more controllable. We don't necessarily need the orientation. We just need things to not swing about wildly for this. What I think I'm going to do is I'm going to move my box launchers a little further off to the side. Say 2.5 and minus 2.5 in the X. And we'll go ahead and change the fire velocity to be a little bit stronger, maybe a 14 and a 14. I could also make the fire velocity be slightly random every time you fire. Like it'll start at the core and then change from there. There we go. That's actually a pretty good height. And by starting a little further away, there's less of a chance that we're going to hit off the edge. All right, I'm digging this. Okay, this triangle, awkward shape. Move it over like that. Grab the circle, drop it in the middle. No! Just mirror the sky move. How did we move the sky? Maybe I imagined it. Where's our background? Blue land. It did move. How did our sky move? We didn't move our camera. Actually, that's really bizarre. There shouldn't be any way for us to click and drag the background. But clearly that's what happened. Interesting. Well, I don't think we'll have the opportunity to really worry about it. Oh, God. I'm trying to get this triangle to sit there. There we go, and form a little bit of a catcher. I'm bad at my own game, apparently. There we go. And another triangle. Whoop. Okay, I'm digging it. We want a loss condition now and a point condition. And also, we need to answer the question of what happens if we grow so tall that things are going off the edge. So, those are going to be the three final things. We need to move the camera if we get too tall. We need to score points as we grow, and we need to lose if something falls off. In fact, I think our pointing system will not necessarily be based on height. What if it's just based on the amount of items that have been launched? I think that's probably pretty good. So let's go ahead and add some sort of score manager. I guess we have mouse manager. We'll have score manager. It's going to be a very simple script. And we're just going to set a public float. No, not float. Integer. Score starts at 0. We'll do a void on GUI. Again, we're using a very simple GUI thing over here until we get the new GUI system in place. We're just going to create a label. It needs a rectangle. We'll put it in the top left corner. Give it a little bit of size over here. And then the text is simply going to be score, colon plus score. So this will just put a little score number in the top left corner. And then our box launchers, every time we fire a box, let's add a point. So what we're going to need to do is we're going to have to find, again, this will be a little bit slow and non-ideal, but that's okay. So we've just fired something. So let's GameObject.findObject of type. We're going to find the score manager and set the score. We're going to increase the score by 1. There we go. So every time we fire anything, we increase our score by 1. Next, we need to say lose. So the way we would lose is we could stick in let's make another empty. Let's call it the death trigger, which is kind of a nice, scary name. And we're going to add a big box collider 2D on this. And so let's center our object. Well, it doesn't have to be centered in the Y. But we're going to make it nice and wide, say like 10 units wide. So if we zoom out, we can see it's really, really quite big. In fact, let's make it like really big just to make sure it can't possibly miss anything. And we'll put this just below the platform. And it's going to be very important, actually, that it's going to be below our box launchers, because we got to make sure that when we launch something, it doesn't actually affect our death trigger. We'll put it a little bit lower. Just for safety's sake, we'll make it a little bit higher and do that. So the idea is if any box hits down here, that's how we lose. So we'll add a new component here called, death trigger, and do that. Now, it's important to note we have our collider here. Right now, it's an actual collider. So if we take it, we hit play, we wait for a box to launch, and just shove it off to the side, the box will land on it, which probably isn't what we're necessarily looking for. We're probably mostly just looking for it to be a trigger. So if anything goes in it, it'll fall through, but more importantly, it fires off as a trigger. In practice, it doesn't really matter which way we do it. It'll just affect what function we use inside of death trigger. Are we going to use on trigger enter or on collision enter? Personally, I think that logically it makes more sense to be a trigger, but either one will work. On trigger enter 2D, what I think this is called. So this will fire if anything enters a trigger. Technically, it will feed us a collider in here that we could reference, but we don't care about that. We just need to say that, hey, game over. So we're going to do, I don't know. What are we going to do? Maybe what we'll do is we'll just have a variable. We're going to keep this really simple. Has lost equals false. So when something enters the collider, we set has lost equal to true. And again, we'll do a very, very simple on GUI. We'll just alert people of the state. If has lost, then we're going to do a GUI.label. We'll put it in the center of the map, which means new rectangle. We'll say it's got a width of 100, so we can do something like for its position, we can say screen.width divided by 2 minus 50. Screen.height divided by 2 minus 25, and that makes a width of 100 and a height of 50. And then we just put in the words game over. And we probably shouldn't get any more points at that point. In fact, we could stop spawning if we're game overed, for example. So let's make the has lost public. And over here in our, say our box launcher, if death trigger, no, game object, again, this will be slow, but we'll deal with it. Find object of type, death trigger dot has lost. If we have lost, then we just return. We're not going to fire any new objects, and we're not going to advance our score. Right now, the only way to reset the game would be to reload the page, but we can get a little restart button going on in a second here. So now, if we take this and it falls off the edge, I suspect that this function is not the right word. Let me go and see if I can... We have rigid bodies. It's the right function name. On trigger enter 2D. Debug.log. I should definitely be firing. Yeah, it fires. Okay. Since has lost to true, why aren't we getting the label? It's definitely firing. Minus 50. Yeah, we should be getting our game over here. Let's see if the boxes stop spawning. Yeah, well, definitely it should. So we get the on trigger enter. Our launchers are no longer launching. Oh, we're not getting any text. No. Oh, hold on. It's because it's white on white. It just barely can't see it. It's because it's white on white. That's fine. We can fix that. GUI.color equals color dot black. That should set the default color for these various components. We'll do the same thing on the score. Let's try that. There we go. And now if we lose, game over. Okay. Again, very, very, very simplistic GUI sort of thing. Just to get things technically working. We'll add a way to restart. So we'll put a GUI.button right underneath it. It needs another rectangle. We use the same code as we've got here, but we'll add, say, 55 pixels to the vertical position. That does that. So that'll put in our button, and what we can do is wrap this if button. So if the button gets pushed, we'll restart. The easiest way to restart here will be to do application.load level. It can take a string or an integer. What we can just say is application.level or loaded level. So that'll tell us the current level. We just tell it to reload the current level, and that will reset everything. Let's give that a try. So we do that. We get game over. We restart. And there we go. We're playing once again. And we'll do a better GUI at some point in the future. Now that 4.6 is out and the new GUI system is out, which I'm very excited for, we can do some tutorials on that. But there we go. So the only thing missing now is the idea that maybe the camera should move as you get higher up. So how are we going to do that? Well, I think what we should do is any time there's a collision between sort of these objects here, which is basically when it happens when it stacks or whatever. What if the camera is lower than wherever that collision occurred? Let's move the camera up to where that collision was. So we can do that pretty easily. So all of our boxes here, on all of these objects, we could add a script. Yeah, I'm going to make a script that says collision handler, maybe. Something like that for our prefabs. That's in the wrong place. Come on, come over here. And then what we're going to do is we're going to add this to our box, our circle, and our triangle. So the job of this thing is when we enter a collision. So void on collision enter 2D. We're going to grab the main camera, which is set to camera.main. This will point to the main camera if and only if your camera here has the tag main camera. If you deleted your camera and then added it back into the scene, it will probably be untagged. So make sure you have it tagged as main camera. If you have that, then camera.main will refer to your main camera. So we're going to say something like if camera.main.transform.position.y is less than this object's position, transform.position, then what we're going to do is we're going to set, .y. Then we're going to set the camera position. Actually, I guess we'll grab a copy of this. Hold on. Vector 3, because we can't edit it directly. Cam pause equals this. And then we can compare cam pause y. So what we're going to do is set cam pause y to be equal to transform.position.y. And then we're going to feed it back in. Camera.main.transform.position is equal to the camera position. So now, every time there's a collision, now what we have to remember is by default, the camera position is at 0. This is the 0 line. Anything occurring below this will have a negative y, so the camera won't move right away. But once we get up higher than that, then the camera will want to start moving. Now, it's going to be very jerky and wrong right now because it's going to be... I should just change it to only be boxes right now for testing. Because it's going to teleport the camera. That might be high enough. Boop, there we go. You can see when I boomed over here, it moved the camera up. And then we got some game overage there. So that's not, that's the sort of effect I'm wanting to go. But obviously we don't want to teleport the camera that way. We want to move the camera slowly, gradually. So I'm actually going to add a script to the main camera called something like camera mover. And so it's going to have a very, very simple function. On camera mover, it's going to have a public float target y. And it's going to default to 0, our current position or something of that nature. And in our collision handler, instead of setting the camera position directly, we're instead going to say camera.main.getComponent camera mover .target y is equal to transform.position.y. So we're going to tell the camera, this, you want to be at least as high as this object is right over here. So in the camera mover, we've set the target y, and then it's an update. We can just move the camera towards this target y. There's a bunch of different ways we can do the move. We can move at a constant speed. I think what I want to do is do a lerp because it's a nice sort of smooth movement that will slow down as it approaches the target. So technically, mathf.lerp takes two numbers, from to. So we're going from the current transform.position.y to the target.y or target y. And then the final parameter is time. Now, when t is equal to 0, if it's at 0, math.lerp will simply return this first number. If it's at 1, then it's going to return the second number. If it's somewhere in between, it'll return a number that's a blend of the two. So if I were 0.5, it would be a number that would be exactly between these two locations. Now, what you can use the lerp for is you can use a sort of a time variable over time. So, if we had some sort of float t equals 0, and then every frame we might do something like t plus equal time dot delta time. And then if we just pass t, then over the course of 1 second, we would move from this position to this position over the course of 1 second. And it would do it smoothly and be very nice. A common trick in Unity, instead of like feeding it an actual time, is to just feed it in a number like something like 0.1 or 0.1 or say 1f times time to delta time. Here's the thing. If you pass it some small number, actually, here's a better example, better way of explaining it. If I say 0.1, and it's a floating point number, of course. If I say this, then what it will do is it will give me a number that is 1/10 of the way towards target y. So it's 90% this and 10% that. And if I set my position, vector 3 pos equals my current position. If I set position.y to be equal to that, and then I set my transform.position back into the position like that. Okay. If I do this, every frame, this runs every frame we will get 10% closer to our target y. Now you might think that means in 10 frames we'll get to the destination, but that's not the case. Because let's say we're at position 0 and target y is 10. So in the first frame, this will return, it'll be 10% of the way. So it'll go from 0 through 10, 10% of that is 1. So it'll return a y of 1. So now we are at 1. The next frame, transform.position.y will be a 1. This will be a 10. The difference between these two is 9. 10% of 9 is 0.9. So now position.y will suddenly become 1.9. And the next one, it'll be 1.71. And so on and so forth. No, it'll be 2.71. It will get closer to the target, but it will get closer by smaller and smaller chunks. So this is every frame, which means it's not quite constant because we don't know what our frame rate will be. So it might be good to do something like a use time.delta time. And if we did something like 1 times time.delta time, then this would mean sort of over the course of 1 second we'll get to our destination, but it actually won't work out that way at all. In fact, just back of my brain limit stuff, won't this like approach our destination over 2 seconds, or I'm not sure. Anyway, if we do this, we will smoothly move towards our destination. Let's give it a quick test. Let's actually, we can make this a little bit easier. If I take my main camera, instead of starting at 0, if I started like below the horizon like this, then when it shot out the block, oh, actually, there we go, because we set our default target to 0, so it will properly pull up. And you can see this nice smooth kind of motion, and then it'll stop at the kind of target location, and then if we keep stacking boxes over here, there we go. Keep giving me boxes, game. There we are. There we go. You see that? Had to move up just a little bit. And I think that's quite nice. And because of our structure, we're not going to be able to place this anywhere, so it'll fall off, and we will lose. Game over. But hey, that's kind of fun. I'm going to go ahead and restart the main camera back at the 0 position, because I think that's going to be fine. Or I suppose I could be like slightly lower than the platform, and then we get a nice, as we start, a bit of a pan up to that, get a sense of like upwardness. If I take this and sort of shovel it that way, we can get a nice little shape. All right, you know what? I think we've got ourselves a game. Now, of course, we don't have any sound, but sound's always, some other thing that you can add in. I have a sound tutorial or a couple of sound tutorials already that you can check out, and we might revisit sound in these things a little bit more later on. But there we go, and I'm getting a point every time the box is firing. So I'm curious to see what kind of score people can get. Of course, it'll be greatly influenced by their luck at getting various objects. You might want to get rid of these super circles, or maybe they're really good. And again, this is a game that should work properly on a tablet as well, or any kind of mobile device. You should be able to drag it around with your finger and see how things go that way. Boop, put that down over there. Put down there. Different shapes. Maybe if the triangles were smaller, maybe if we had hexagons, maybe if things were just stickier. No, don't fall off. And you're sitting here trying to like wrestle with things and staying on, and Oh, that was a poor game. Only 9 points. Anyway, folks, I hope you enjoyed this tutorial. And let me know what kind of tutorials you might be interested in the future, and I will certainly endeavor to do that. Certainly, one of the things I would like to do with 4.6 out is take a look at the new GUI system. So hold on to your pants. Hopefully, we'll get one of those relatively soon. See you next time, folks. Bye-bye.